All right, let's get started. Welcome to Lecture 19, CFC 5323, 7323, Mobile Sensing and Learning. How's everyone today?
Good.
Excellent. What's that?
The build conference going on today.
All right. Very happy. That sounds good. Excellent. Okay, course logistics. A4 grades are still not up, but they will be soon, I'm hoping. A5 is due this Friday. How is everything going with A5? 100% good, not so good. How are you guys doing with sensors? Yeah, okay. Potentiometers. How many of you guys are using potentiometers as a sensor? Do you know what you're using yet? What is it?
We can't do EE. We're struggling.
This is not EE. This is hobbyist electronics. All right?
Same thing to me.
Okay, fair enough. That's fair. That's fair. I will give you that. I will give you that.
But where will be here for lab?
You'll be here for lab. Okay. If anybody, I know that I had thrown a bunch of potentiometers, and I know that some groups were like overlapping on who thought who had what for a sensor. So let me know, and I just want to make sure that everyone has something that they can work with, and they can prototype with. So we can take care of that during lab tonight too, as well. So it is time to really start thinking about the final project proposal. So let's give a brief discussion about what I want from that, because it's due at the same time as A6. Not A5, A6, okay? And A6 is the last lab. There are surprisingly few weeks left in this semester, okay? I think there's like 7 lectures and then we're done, all right? Okay, the final project demonstration. I want you guys to create an I/O application that uses techniques from basically all the programming that we've done in class. You have to use techniques that we've learned from at least 3 of the different labs, okay? Right? So if you were to do something with audio and core motion and it has a user interface, I'm giving you that for free, okay? All right? And it has a user interface, then you've used 3 things, okay? Right? So if you do that and you make it as difficult as, I'm saying, it should be at least as difficult as 2 lab assignments, okay? If you make it as difficult as 2 lab assignments, you incorporate all the things in there, that will get you a C, okay? On the final project. If you go above and beyond that, that's where we start to move up. That is the bare minimum, though. Does that make sense? Yes? Okay. So part of what I'm going to be grading you on is what you propose. Okay? I'm not going to be grading the proposal, but what you propose is what's going to come due come final demonstration time. Right? So during finals, we're not actually, there's no tests in this class. You're going to be pitching your application to me. Good. We have a storm. So you're going to pitch your application to me. You're going to get basically 5 minutes, and then there's 5 minutes of questions after that, where you demo the app, you show me everything that it was going to do, and I basically go through and make sure that it does all of those things, right? And you have to have a plan for showing me how that works, okay, during the final project demonstration, okay? So that proposal, basically the proposal is going to come due with A6. It's a paragraph describing what this application does, you know, kind of what you're thinking about doing, and then a set of 4 or more constraints that your application is going to meet, okay? So let me give you, and also, if you guys are doing the mother of all demos, which means that you wouldn't have to do this Kickstarter webpage, but you have to meet all of the constraints, and the constraints that you give me are going to be somewhat more difficult. If you're going to be doing the mother of all demos, I have to know when you propose the proposal, right? You can propose to do the mother of all demos and then decide, hey, no, we're opting out. We're not going to do the mother of all demos. It's too difficult and it's too risky for us. We're going to do the webpage. That's fine. You can opt out. You can't opt in, right? So when you put your constraints to me, I need to look at your constraints knowing that you're going to do the mother of all demos. Okay? So it's an opt-out, but you can't opt in later on. Fair enough? All right. So an example project that you might do. This would be called, the application would be called Jukebox Hero. Okay? I get a couple of laughs. Thank goodness. All right. So this is the best thing that I could come up with that was like a mix of Guitar Hero and Foreigner slammed together for an iPhone application. All right? If you don't know who Foreigner is, that's fine. You were probably born in the 90s. That's fine. It's no big deal. So this application, you would say, we will build an iOS application that works as a guitar pedal. We're aiming for users to be musicians who want to play along and practice songs for their music library. The phone will allow a jam session. Okay, so users connect their guitar and listen via the headphones or external speakers. It'll have 5 different guitar effects, including distortion and chorus. Okay, some effects will have varying levels of tuning, right? So like the amount of distortion that would be on an effect. Then you would say, the app will play songs from the user's music library and will consult our web server for information about the songs, like the tuning of the guitar so that the user can play along, right? So if the guitar is in a different tuning, you can actually tune your guitar to what the song is played with, right? And then you're going to say, and it'll allow the users to tune their guitar to the song that's being played, right? So you'll have a tuner app that's part of your application. You play a song and it tells you whether it's E, A, D, G, B, E, okay? We will allow control over the effects through core motion. For example, moving the phone with your foot controls a predefined progression of different effects, right? So as you're playing guitar, you can do something with your foot, and you can actually switch the effects that you're playing with, okay? It's a guitar pedal. An example of the closest app on the App Store is, and then give me an example, all right? If there's not one, tell me. The constraints to be met in the project are, and this is very, very important. Don't just throw this together because you will give yourself enough rope to hang yourself with, okay? Put your constraints, think very, very critically about the constraints that you want to put forward, okay? So, number 1, recognition of a foot gesture. We will validate our recognition by teaching the instructor to select through the foot gesture. Then allowing the instructor to use the foot select to change effects. We will have at least 90% recognition, okay? Number 2, 5 different effects will be implemented. At least 2 will be tunable, and we will evaluate by showing a progression of effects through external speakers and connecting a guitar during the final demonstration. Right? That's perfectly fine for an evaluation. We will have a tuner in our application for tuning the strings of a guitar, and we'll demonstrate this with a guitar during the final demonstration. We'll also show the output of a real tuner for reference. The phone and tuner and the purchase tuner will be no more than 1 hertz apart. Right? Okay. The last constraint, something to do with the web server. What might the last constraint look like for this application? Web server response time under 500 milliseconds. Okay? So the user can sit there, they can query, it's like, hey, I'm going to pick out a song. Maybe it's something like, or maybe this has something to do with the way that you're going to play the song from the user's library. Like, we're going to allow you to, basically pick a song to play with. It's going to go out, consult our web server, see if we have that in our database, right? Or you could actually, you don't have to host your own web server. You could be querying something like guitartab.com, right? And seeing what the tuning for this song is so that you can display it back to the user. It's like, hey, we need to tune it to this, so we're going to allow you to tune your guitar with that. Okay? This application, if you guys chose something like this and you did every single one of these, you would get an A++ on the final project. Okay? This is a difficult project with a lot of different pieces. Yeah.
So the difference between doing this with the mother of all demos and the not mother of all demos is if you do the mother of all demos and you drop below 90% recognition.
If you drop below 90% recognition, you fail the mother of all demos. If you're 89%. If I do this 20 times,
demo, what happens if you drop below 90%?
If you do the regular demo, then that constraint gets graded down a little bit. And but you still got a mass of other percentage of your grade that comes from the web page, right? If you're doing the mother of all demos, if you fail the mother of all demos, that web page is due. Okay? It is all or nothing. If you pass all of the constraints, you get an A. No final, no summary, nothing. But these constraints are going to be difficult. Like you might say 90%. I'm going to come back and say, no, it needs to be 99%. Okay?
Are you going to create it again after the initial demo, like on your own time? Or is it just going to be that section?
I will look at your code base just to make sure that things are implemented. But for the most part, I mean, most of it is going to be like you've met these constraints, right? And how you display that you've met these constraints to me, right? Like it's important how you evaluate that and show it to me. Right? So 90% recognition, you could have me do something with my foot 20 times, and 18 of them have to come out the way that I think. Right? Good? Yes? Questions on the final project, proposal? If questions come up, email me, stop me in class. There's a couple more lectures before this thing comes due, right? So, or a couple more weeks. Okay? All right. Moving on. So the agenda for today, we're going to finish off MongoDB, and then we are finally going to get back to iOS. We're going to start doing HTTP requests, and I'm going to show you some of the new stuff that's in iOS 7 for doing HTTP requests. Doing requests on the iPhone has gone through a lot of different iterations, and it's really stabilized into something that is, I consider, very top-notch. Okay? Okay, so MongoDB, just as a very, very quick, stands for humongous data. We went over that last time. It is the leading NoSQL database, and it uses documents. What's a document? A big file of JSON. Basically, it's key value pairs, right? Or key array pairs, right? What do I mean by key value pairs? Wake up. What do I mean by key value pairs?
Like dictionary.
Yes, yeah, now everybody's back. I know it's raining, things are going on, but we're here. We're here now. Let's be excited about this, okay? Last lecture, I felt a little by the end of it, okay? Not this one. We're going to do really great this time, okay? Everything's stored as a document. And the schema is dynamic, right? I don't have to define that I'm going to have a table and I'm going to have a bunch of different like floats and strings and this is going to be there. I don't have to define that beforehand, right? It just can evolve as my schema evolves. Right? As I get more users and I decide I want information, I can just start saving it in the database. Okay, so when you want to install MongoDB, you essentially need to go to their website, download it, install it. It's gonna you're gonna download it as a .tar.gz, and you're gonna extract it, and then you're going to make a directory where you want the database to be. Okay, so use data/db. Right? That's a directory where everything is going to be saved. Then you're going to go to wherever you downloaded that tar.gz and extracted everything, and you're going to type in this MongoD, and you're going to give it a command line argument, which is, here's the database path to DB. All right? So this would be data/db in my case, if I'm running from the same directory, or wherever that directory is that you want it to be saved from. Okay? So it's running, and it's running localhost on a default port, I think 27,000 something for the port that it's running on. Okay? Make sure that database exists, or when you run this terminal command, it's going to have an error. Okay? Good. All right. So, a document. You can look through this on your own time if you really want to. A document is really just, it is very easy to internalize in your head. It is a key and a value, okay? Or an array. Right? That value can be anything. It could be binary data. Okay? It could be a string. It could be a float. It could be an int. It could be a bool. Okay? You can type it however you really want. Okay? All the primitive types are supported. Okay. So a document is going to be, this is the lowest level that you have inside of this database, right? So this right here would be one document entry, right? So this is one document entry that says Team Mongo. Members are Eric, Ringo, and Paul. The number of apps that they've written is 21, right? Me and the Beatles, we go way back. And then the website that they have is teammongo.org. Okay? Wonderful. One entry in a database isn't very cool. All right? What is cool? 1 billion entries in a database. Okay? You guys are tough. You're tough today. What's up?
Is the whole database a single file with all of that inside,
Um, it's binary. It is a binary serialization.
But it's one single file. Like if you look at the folder, it's going to be like something database.
You are not going to be able to look into the folders.
Oh,
I mean, it is binary data. Okay. And I mean, thinking about the database as being on one computer, don't even internalize it that way, because you could have a database that is spread across computers, right? And they all have access to the same database, or they all have a piece of the database, but it's this soft file system, all right? So think of it, the file system exists, and that database that's how you mediate access through it, okay? It's a pretty good way to think about it, all right? So if you have more than one document, and those documents are in some way related to one another, you put them into what's called a collection, okay? And a collection, they don't have to have all of the same entries, right? So here's my teams collection, right? So my teams collection here has a couple of other document entries in it. Like here's another team which is ran off, and the members are John and Yoko, right? And the website is flewthecoop.org, all right? Then I've got Team Shatner down here, which is Bill, Will, and Tom. Now notice that like the entries in here, they're not identical, right? This is not it's not a table, right? This is a collection is kind of equivalent to what a table would be in a relational database, right? But it's just there's some underlying similarity between these that exists. Okay? So I could also have a collection of applications. So like here's a Mongo app. It has roughly 100,000 users. There's a step count app, right? So all of these applications exist right here, right? So these are two different collections.
do they have to have at least one similar key to be in a collection?
They don't have to. They really should. Okay? You're not required to. I mean, they could be completely different. But if they're completely different, why are they in the same collection? Right? Because usually what you're going to do is you're going to look at a collection and you're going to do a query on a specific collection, right? So it's kind of how you control some of the queries that you do. Like you would query a table that's inside of a relational database. And if you want to do something with a bunch of different tables, you would like do a join, right? And you'd be able to look through them. With a collection, it's kind of the same way. There's something similar about these documents. And they're going to have one key that is probably the same that you can query on and select things from, okay? If you take a bunch of different collections and put them all together, that is what is a database, okay? So the database, so this could be the database MSLC creations, _creations, right? And it would have these collections inside of it, right? So that's what I want you to internalize as the structure for how MongoDB is set up. Database, collections, and then in each collection a bunch of documents. Okay? So now that we have that internalized, let's talk about how to access those, how to insert, how to query. Okay? Questions on the setup. Pretty simple. Pretty easy to follow. I agree. Yes?
Can you have documents instead of documents? You know how you have the curly braces and you have like...
Can I have a document inside of a document?
Yeah, like...
Absolutely. Yes.
Yes?
Yes. Yep. Yeah, that would be like a one-to-one relationship. Yeah, you can have a one-to-many, right, where you have a key and lots of different documents inside of that key. Okay? And if it makes sense for your schema at the given time, then go ahead and do that, right? Even though this has a dynamic schema, it doesn't mean that you shouldn't have a model for your data in mind, right? You're always going to have that. It's just this gives you the freedom of not absolutely defining what that structure is. Okay, so when we use MongoDB to access things to it, we're going to use PyMongo, which is a Python wrapper. It's written for using MongoDB. The way that you use it is pretty simple. It's very Pythonic. What you're going to do is you're going to get access to the client that is running localhost, right? We are going to run it localhost. And essentially, the way that you get a handle of that client is you just run this function Mongo client. And then you can get an access to some database. So I could say client.somedatabase equals DB. That is now I have a handle to the database inside of MongoDB. Okay? Some database doesn't have to exist yet. All right? So create this database if it doesn't exist, right? That is what that line of code will do. Not exactly, but we'll get to that. Okay, think of it right now that that's what that line does. Okay, so maybe we've got some database and we want access to some collection. All right, so create this database if it doesn't exist, and then create this equivalent here of a relational table, right, which is our collection. So create that collection inside the database if that doesn't exist. Okay. Nothing is created inside of MongoDB until you insert something into the collection inside that database. Okay, so that's the caveat there, right? Now, the second that you call db client.someDatabase, it will actually start talking to the server. So it will open up a connection to MongoDB, a localhost connection. Okay, and it'll be live until you close that connection. And the way that you close it is client.close. Okay. All right. So now I can actually run one of these Mongo functions. So if I were to say db.collectionNames, this is a function that I can run on it. I'm going to get back all of the names of the different collections that are inside that database. Okay, right? So some collection was one of the things that we put in there. And then there's this system.indexes, which essentially tells you everything about all the different database. It's a lot of schema that is saved for the database. Most of the time you won't use that. Okay, but it does exist, right? So if you call collection names, system.indexes is going to be one of the things that it returns. Okay, so that will get you the collection names if you don't know them already. All right, if you want to do insertion with PyMongo, then you are going to use the .insert function, okay? And the way that you insert something is through using Python dictionaries, right? Dictionary is it's the equivalent of like a JSON entry. It's a key value pair, right? So if I wanted to insert this where my key is key 1, which has some values in it. Values is some variable. And key 2 has more values. Right? I don't have to make key 1 and key. This key can be anything, right? So this is cool key with cool values. All right? And what I get back is a DB ID, which is a database ID, right? Essentially, if you were to look at the fields of this, it would have an extra field, which is _ID. That _ID is a unique key for that document. Okay? No other document gets that ID. All right. So that is for insertion, right? So that's going to insert that into this collection. Now, if I want to update that value, right? So maybe I don't know if that value exists. I don't want to perform a query on it, but I want to update it if it does exist. Then I can actually use this right here. So I can use the .update function. Okay. The .update function takes a couple of different arguments. The first one that it takes right here is where you want to update. Right? So wherever the key is, this key, and the value of that key is equal to, let's say, key value right here. Right? Wherever this query is true, then set the key to set and the value to set.
How does update handle it if you pass in a key that's not created yet? Does it create it for you?
Yeah. So default, the question is, how does update function when something doesn't exist, right? So if that key doesn't exist, then what this is going to do is, if you don't give it any other options, it's going to fail. If you set this little thing down here, upsert equal to true, then it will insert if it doesn't exist. Okay? Right, so upsert is kind of update, insert, jam back together as one word. All right? I don't know. This is y'all's generation. You guys did this to me. Okay, so questions about insertion and updating, right? So this inserts one document. Okay, we will go over how to insert multiple documents. Okay, and this updates one document.
Is there a range of types for the actual value or array type? Does it have to be a single value or like an array, or does it take lists also?
So it will take an array, right? As it'll take a list, right? It'll take a list of primitives, right? So ints, floats, strings.
So would the update function find any documents that match that key?
Yeah. So this update, anytime this key is met, right? Anytime it finds a key in the database that has this, anytime that's true, it's going to set it equal to that.
I just select like a specific document. Like you don't want to change all of them.
You don't want to change all of them. Yes, you can. Essentially, the way that the best way to do that is the underscore ID equals this. You're guaranteed that it's unique in that way, right? Normally, when you do an operation like this, you're trying to update all of the keys for some reason, right? So this would be anytime that this key equals true, I want to change the value to this, right? If there's a specific document that I want to manipulate, maybe I read it out, I manipulate the things that are in it, and then I upsert it where everything is essentially that ID stays the same. Right? Okay. So if I want to use PyMongo to perform some queries on my database, I want to find one datum in my database. Okay? I can use the find one function. Okay? So in this right here, what this is going to do is I want to be equal to, okay, so in this collection, I want to find one. And essentially what I'm going to say is, I started off with this example. That's okay. This is, I want to do a sort operation on this key, right? So essentially what I'm telling it is find one. So do a sort operation and get me the last value, this -1. Right? You can also call find one without any arguments in there, and it will give you the very first thing in that collection. Okay, it'll just immediately return the first document in that collection, right? Or you don't have to say sort here. You can just give it a tuple, right, or a dictionary, right, which just says the key equals this. Return the first document where that's true. Okay, that's the find one. So now when it returns A, that is literally, it's a dictionary. Right? So I can manipulate A, right? So sort on this key, that's one of the keys that I sorted on. I can access that key using a dictionary entry, right? Pretty simple. So A at the sort on this, and I can convert it to a float right here and say, hey, so this is new data, right? So this is one of the examples in Python where I'm actually defining a type, right? Okay, good. Okay, so sort with this key. Get the last element. Also, this right here, my sorting parameter, right? It's a list, right? So I can give more than one element inside of this sort list, right? I can say, okay, first sort on this key. If more than one entry comes back, do another sort on it, and then grab the very last element, right? So I can give it as many tuples as I want inside that list. Yeah? Yeah. And then I can access the result. Okay. Usually I want more than one document when I'm querying something, right? So the way that I do that is with the .find function. Very, very intuitive. Wonderful. Okay, so I say f equals some empty list. And then I say, okay, I'm going to actually loop through this with a for loop. So for a in some collection.find, I'm going to give it the key I want and the value of the key that I want, right? So anytime that this is true, I want you to loop through all of them and append that value into my list. Okay, and what I'm actually going to do, I'm going to grab A at the key to grab data with. I'm going to turn it into a string, and I'm going to append it onto the list. There's lots of advanced queries that you can do with this, greater than, less than. We're not going to use all of them that are out there, but you're welcome to look at them if you want to. You can go here. This is a great tutorial on how to use PyMongo and how to do a lot of different very involved queries. Okay? This will get you through everything in this class. All right? Because A6 is a beast. Who's afraid of A6? There's 2 people that are sane in this class. No, you're not. There's 2 people. There's 2 people. If you're not scared of A6, you should be. But by the end of this lecture, you won't be because I've written almost the whole thing for you. Okay?
Oh.
I know. Jeez. All right. So let's go through a Teams example. All right. So I open up a console. I say from PyMongo import Mongo client. And I say, hey, client equals Mongo client. What have I done now?
You start a connection.
I started a connection. I've got a connection to localhost port 27,000. Okay. Now I'm going to say db equals client.sum database. That gets me a handle to the database. And that gives me a handle to the collection called sum collection. All right? Now I'm going to insert a team into there. Okay? So collection1.insert. I want the key to be team. So the team name is team fit. And the members are Matt, Mark, Rita, and Gavin. Okay? So there's team fit. And they go into the database. And when I actually execute that command, it gives me back the database ID for them. Okay? That's the database, that is a unique ID that we talked about. Okay, so if I run db.collectionNames, yeah.
Should you store those IDs like for like after it returns that, will you be able to access them again, or should you like store it?
If I want to access them again with that object ID, I mean, it depends. It depends on what you're doing. If you're going to need that again, yeah, save it. Right? Otherwise, you can perform a query on the database later on. Right? Like, you may not need it now. You may need it like a year down the line. Right? And so you would have to form some kind of query. Right? So maybe maybe I'm going to get through this, and then next semester I'm going to come back and I was like, oh man, I also need the year that these teams were actually in this class. Right? So I can do that. I can just add that in for all the new teams to get out there. Okay? So if I do db.sumCollectionFind1, what's it going to return? The very first document. And I've only entered one thing. Right? So bam, it's going to give me back a dictionary that looks like this, where I've got the ID, and it's got an object ID right there, and then it's got the members of this team, and the team name, which is team fit. Okay? So the entire thing comes back to the dictionary. Okay, so now I'm going to insert another team. So here's team underscore, and the members are Carly, Lauren, and Cameron. Okay? Get that. I can see people's faces like, oh, yes. All right, this is good. So I get an object ID back. Now if I do sumCollection.find1, what am I going to get? I'm not going to get an error. It is going to return something back to me. It's going to return team fit. Why? It's the first one that I entered in the database. That is the first document in the database. Okay? Okay, so now if I do db sumCollection find one, and I want the team to be underscore, surprise, surprise, it's going to give me that team back. Okay, so that's how I would do a query here, right? A little more concrete now. We've gone through an example, feeling good about ourselves. All right, let's make it confusing. Okay, so bulk operations. I can run a script from PyMongo, import Mongo client, get this, all that stuff. Now what I want to do is create a list of dictionary entries, right? So this is a list of things that I want to enter, right? So my insert list is going to be team, much code very well, members, Matt, Rowdy, and Jason. And then I've got team CHC, members, Hunter, Chelsea, and Connor. Okay, and I'm going to enter these two teams now into my database, right? The way that I do that is still with the insert function, except I've given it a list, and so it will one by one enter each of those. What, did I spell the name wrong? What's going on? No? Did I forget somebody? Like, oops. Okay, so now I can go in and I can say for document in collection1.find members Matt. Now this is interesting, right? Because members here is an array, right? And so what I want are anytime that Matt is in that members array. So if I print the document out, what am I going to get? If I print each of these documents. Who's using Siri? Team, much code very well. here's what I'm going to get. I'm going to get these two teams. Much code very well. And team fit. It was on another slide. You guys are sleeping. It's fine. Okay. Right? So you can perform these types of queries where as long as Matt is in that members list, and it will come back and it will return true. Okay? So if I actually wanted to, now I've got some, I need to disambiguate a little bit in that query if I want to get that team. I could say, okay, I want members equal to Matt and the team is equal to MCVW, right? And then that would actually just return the 1. Okay? Good? Happiness? Okay. That is MongoDB. All right? There are lots of things that you can look up about using MongoDB. This gets you through all of the basics. Okay? And the basics are all we have time to cover. All right? So we're going to use MongoDB as a cool little database, and you're going to have some experience with it. And what we are going to do is we are going to combine MongoDB and Tornado in our Python framework, right? We're running a web server, and now we've got a database for our web server. So we went from a web server that's not very cool to a web server that's kind of cool. All right? So now we're kind of cool. So we'll use PyMongo and Tornado. MongoDB runs localhost. All right? So when I'm running MongoDB, no one else can access it unless they are localhost on the computer. All right? Tornado, we're going to use Tornado to mediate access into MongoDB, right? So any queries, anything you want to do, you're going to submit it to our web server, and it's going to go behind the scenes and do some stuff in our request handlers in Tornado, access MongoDB, do anything we need to do with it, spit something back out. All right? Just kind of like you would use a database normally, right? This is good for learning. If you were going to use this in a real product, you've got to do load balancing, okay? Which means you need an Nginx front end, okay? Yeah. So if I send you out into the workforce and you don't have an Nginx thing and you take it to your boss and they say, well, you can only, you got a Mac Mini and it can only serve about 3,000 users at a time. We need to serve 11,000. You can't come back to me and tell you I didn't tell you so. Okay? All right, fair enough. Good. All right. So there actually is some sample code out there. Someone's been working on a non-blocking MongoDB plus Tornado front end, and that's called Motor, like Mongo and Tornado together, Motor. And it's in an alpha stage. You can look it up on GitHub if you want to. I haven't used it yet, but it actually looks like it does a lot of the functionality that I would want it to have. And it executes things in a non-blocking way. So you can go ahead and take a look at that if you want. If you want to use it, man, that would be awesome. I haven't used it yet, so I'm not going to make you guys use it. Okay, we're going to write our own, and it's pretty easy. Okay, so let's do a very quick demo. In this demo, what I want to do is I want to run my web server. And I want to store data inside of MongoDB with every single GET request that I have. Okay, so somebody does a request, I want to actually store the query and timestamp it, okay, inside of my database. So let's do that. Okay, so this is our Tornado example from last time, right, where we are running on port 8000 by default, and we've got a bunch of different handlers in there, right? What was one of the things about the handlers that was important? What do they inherit from? They inherit from base handler. What is base handler? Something I wrote to help you. Fair enough. Good answers. All right. So what we will do here is I've got this little thing called save to database. Okay, so if I'm running this web server and I actually go to the URL where I have saved to database, what it's going to do is it's going to look at this example handlers that I've done. So I have import example handlers. And it's going to look at example handlers dot log to database handler. Okay? So where is log to database handler? It's in example handlers. Yes, absolutely. Good check. So I'm going to go up here to example handlers.py. Let me click on it. Here's my example handlers.py. And there's all of these different handlers that I was using in Tornado example. So I have example handlers.test handler, test handler, there it is. It inherits from base handler, and it writes out to the screen test of hello world. Something we did last time, right? Okay, so let me go back to tornado example. So we will go in and look at log to database handler in just a second. One of the things that I've added into the application right now is this. Well, up here at the top, from PyMongo import Mongo client. And then I've got this self.client equals Mongo client. And then I've got self.db equals self.client.example database. Okay, what is the name of my database? Excellent. We're working this out. Yes. I haven't asked a hard question yet. All right, this is good. Well, maybe I have. I just don't remember it. Okay, so we can access these through self.client and self.db. All right, and actually, if you go in here to base handler, yeah, we'll go ahead and talk about it. Those are actually two properties that I put inside of the base handler class. Okay, so when you say self.db from your base handler class, it's actually going to give you a handle to self.applicationDB. Application is the tornado application. You don't need, anyway, that's just how it's working if you're trying to add properties into the application. Okay, for us, we're going to go down here to the logged database handler. And this is for every GET request that I get that comes up to this logged database handler. What I'm going to do is I'm going to do self.getArgument. And as long as arg is in the query, then I'm going to get the value of arg back that's in my query as a GET request. Okay? I'm going to grab a timestamp, which is t equals time.time, like this. Time.time comes from import time, Python. Good. Excellent. And now I'm going to say, okay, the database ID is equal to self.db.queries.insert. What's the name of my collection? Queries. What's the name of my database? Example database. So this is example database.queries. All right? And I'm going to put in there arg, the values, whatever the user sent up that was inside of this arg. And then the time is equal to t. And then I'm going to call this function self.write ID. And then I'm going to send back the database ID as a string. All right? So let's do that. Shall we run this? Let's run it. Shall we Google it? Let us Google it. Okay, so I am in the tornado. There's example handlers.py. Okay, so here, this is tornado example.py. So we want to run this. So Python 2.7 tornado example.py. Right? So if I run this, I get an error. Oh no. Let's go find the professor. Let's email him. It's the middle of the night. It's 4 o'clock in the morning. Let's call him. What's going on? What's that? I didn't start the web server. What's going on? Oh, yeah, I'm sorry. Here we go. Terminal. Preferences. Change. 18.5. I'm already at 18. You guys are getting more and more blind. Python causes blindness. Okay? I'm sorry about that. I'm just kidding. Okay, so essentially it's coming back with here, it's like, okay, packages, where's my error? My Mongo client. What's happening? MongoDB is not running. All right, so let me go over here. Oh, here I am. So inside, so I downloaded my MongoDB OS X version 2.4.9, right? So it's right in here. So if I open that up, there's this bin right here, okay? Anyway, it's MongoDB bin. It's fine, you can find it, it's there. Okay, so I'm inside of that bin directory. So now I can run MongoD DB path, one path up, data DB. Good? MongoDB is running. It's waiting for connections on port 27017. Localhost. Okay, so now let's see if I can run this thing. Hey, I'm running. This is wonderful. This is good news. Okay, so let's go to Safari. Let's open up this. Okay, so let's say localhost for 8,000. I'll go there. Oh no, I get a 404. It wasn't found. My default handler. The base handler came back as this. Why? Because the base handler handles anything that's just given to the straight up my URL, right? What I need to do is go to save to database. Okay? So let's go to save to database, right? So save, hey, look at that. Save to database, right? So if I do this, let me hit enter. Oh no. I didn't pass any arguments in. And I didn't handle the error when somebody doesn't pass an argument in to my database, right? So essentially what happens is I go over here to example handlers. It goes in here. It runs self.getArgument. If arg doesn't exist as a query inside of my GET request, it throws an error. All right? But if I go over to, oh, where is it? There. No. If I go over here, my server's still running. I didn't error out. Okay? That's because you inherited from base handler. Okay? And base handler, essentially what it did is it got this GET request, saved to database, an error occurred, and it spat back out what the error was inside of Python. Okay? So it raised this error. HTTP 400 bad request, missing argument arg. Look at that. Wow. Pretty cool. So I just need that argument. So let's put arg in there. All right, so arg equals, hey, look, I've got an arg equals test. What should arg be? First person to say something, I'll put it down. Hola. Hola is what we got. All right. Hola. Bam. Hola is in the database forever. Forever. Until I delete it. All right. So the ID was here. Look at that. I got my saved it in MongoDB. This is cool stuff. This is kind of cool stuff. We haven't gotten cool yet. We can say it's kind of cool. We've graduated. All right. Good. Happiness. Not happiness. Not a whole lot of feedback. I'm excited about this. Okay. Working with your web server. We've got Tornado. We've got MongoDB. It doesn't do us a whole lot of good in an iOS course. All right? So, what we want to do is we want to send data to our hosted web server. We want to do something cool with it. Or any server, for that matter. Maybe we're writing an iOS application and we want to go out and query Twitter or Flickr or the Dropbox API. Right? To do that, we need to formulate HTTP requests. Okay? So we need to form POST and GET requests, or maybe a PUT request. All right? We need to do it in iOS. How are we going to do it in iOS? Has anybody ever done it in iOS? Maybe? Yes. Has anyone ever done a POST or a GET request in iOS? What did you use?
I used ASI HTTP request, the open source stuff.
You used or AF networking? Or you used ASI?
ASI,
Used a toolkit,
Yeah.
right? If you developed an iOS before iOS 7, if you didn't use a toolkit, you were out of your mind, okay? Because it was ridiculously complicated and asynchronous. It wasn't set up well. It was really awful. iOS 7 came out and they fixed it. Okay? It is fixed. All right? So you can still use the toolkit, but what's built into it is pretty good now. Okay? We're going to use something called NSURLSession. Okay? Actually, if you go in, one of the leading things for working in iOS and putting together these requests was AF networking. And that now uses NSURLSessions as its entire backend. Okay? They migrated over too.
What is
It's just a toolkit. It's a toolkit for putting these requests together. And it works really, really similar to the way that NSURLSession works too. Okay, so NSURLSession. How are we on time? Really? It's already 4:20? Okay, so the proper way to configure a session with a server is to use NSURLSessions. It's new in iOS 7. The old way was to use NSURL connection, or even before that, before iOS 5, it was to use this send asynchronous request. Okay? If you go out and look on the web, you are still going to find a lot of different examples of people using NSURL connection and send asynchronous request. If you use that in this class, I'm going to ding you big time. Okay? Use NSURLSession. All right? Why? Because if you go into an interview and they tell you, and they're asking you, let's say you're interviewing with, I don't know, Bottle Rocket, and they make iOS devices, and they tell you they want you to do an HTTP request example. All right? If you use NSURL connection or send asynchronous request, they're probably not going to look very good on that. And if you find code out on the internets and it says init with contents of URL, that you should never, 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 ever use that for networking. Okay? You will not get the job. It is not the way. So what init with contents of URL was meant to do is whenever you get back a local URL, right, which is a local file path, that's when you use init with contents. Okay, so oh, here's the local file. Let me get the data from that file, right? But you can still give it a URL that is out on the web, and it will try and go do it, but it's not the proper way to do request handling, okay? And it's going to block your UI. Okay? Okay, so sessions are a huge improvement in iOS, and they're extremely powerful. There's a lot of different configurations that you can have for NSURL sessions. The Stanford course on iOS development on iTunes, the free one that I talked about way a long time ago, they talk about this. Check it out. As promised, we're going to talk about complementary material to what they just talked about in that course. Okay? So essentially, if you want to use a download task, that's something, go look on the iTunes course website. Okay, NSURLSession. The way that it works is through delegation, right? As always, anytime we adopt a protocol, we're going to say we are the delegate now, and we implement some protocol methods. Okay? It does authentication if you need it. We're not going to use authentication. Who's going to hack our server? Huh? Anyone. Anyone that finds our URL is going to try and hack our server. We're not going to use authentication. It wouldn't be a bad idea to use authentication. Okay? In fact, if you use authentication, I'm going to give you extra credit on A6.
This is like HTTP authentication.
HTTP authentication. Yeah. Okay. So NSURL sessions, a lot of things are implemented for you, like pause and resume for downloading and uploading tasks. And you can set up download tasks as locally saved files, right? So you can set up this task that you want to be completed, which is essentially, hey, download this from your web server, and it will download the entire body of that HTTP request and save it into a file. And then it will, once it's done, it will notify you and tell you where the file is, right? So that you can download and do it in whatever you want to do with it, right? So the advantage of that is it takes care of all the resume and everything for you. It's all in the background. So if you want to configure an NSURL session, it's pretty easy. One of the things is that you will do is you will say that you are an NSURL session task delegate, right? And I'm actually going to take a property, NSURL session. I'm going to call it session, and I'm going to make it a property of my view controller. Okay? So this is the session that I'm going to reuse. So if I want to set up my NSURL session, what I'm going to do is I'm going to say NSURL session configuration, session config. This is another class. And I'm going to get a configuration for the session configuration. You can do one of 3 different session configurations right here. You can have it be ephemeral, you can have it be default, and you can have it be background. Okay? Here is ephemeral. What does ephemeral mean? Does anyone know what ephemeral means? It's a fancy word. All right. I looked it up too. So ephemeral, lasting for a very short time. Okay? It's essentially a NSURL configuration where it's essentially kind of private, right? It's like, do not cache this, don't have any cookies, there's no authentication, don't store credentials. That's an ephemeral session. Okay? It's what we're going to use, actually. So you can set up some different things on your session configuration, such as a timeout interval for your requests. This is in seconds, right? The maximum connections per host, right? A lot of the different things you can actually go through and get through this session config, okay? So now when we want to set up our NSURL session, we'll say self.session equals NSURL session, session with configuration, session config. We set our delegate as ourselves, okay? If you set your delegate as yourself, you better have stated that you implement the session delegate task, session task delegate, okay? The last input on here is the delegate queue. It's essentially the queue that you want your session to run on, right? This is something you set up right off of the bat, okay? So I've actually put in nil right here. Nil means that I want this on a background queue, okay? Not on the main queue, all right? What does that mean for us? It's not going to interrupt the app at all when I'm doing these download tasks. But when I get something back, if I want to update my UI, once I've gotten something back, I need to dispatch it to the main thread, okay? Main queue, right? Just like we have always. Okay, so I want to configure a session. There's other options. The default session configuration, it uses the global cache. You can have cookies and the credential storage options. Okay, so if you were say using, if you're using the Dropbox API, right? Default session configuration is what you'd want to use, and you could set up. It would use the global cache as long as you had used your app to log into Dropbox. You would have these global cache authentication. There's also a background session configuration, which essentially says, hey, make my session respond to push notifications and launch my app if necessary so that I can handle things when my download completes. Okay? This is actually a really, really powerful configuration that you can use because your app doesn't even need to be running to be able to download things or receive push notifications. Okay? Sorry, it doesn't need to be in the foreground. It does need to be running. Okay. So I want to configure a task. Tasks are basically common types of requests that you're going to do, right? They're tied specifically to a session. So it's like I have this URL session, and now I want to do a task. And that task might be a GET request or a POST request, right? So I need to set it up, which means I need to give it a URL that I'm going to be going to. I need to tell it the type of request that it is, right? What do I mean by type of request? Yes. Get, post, put, delete, that kind of thing. There's a bunch of stuff. Most of the time, get, post, right? When you set up these tasks, a task will format the data in a specific way to handle a response from the server. So the response is going to come back from the server, and it is going to format the data that comes back and give it a specific format, right? So that's probably a little unclear. It'll be more clear in the example. Essentially, if you want it to come back as NS data, it'll come back as NS data, and everything will be cast for you. When we do this, we're going to use a completion handler, which essentially means we're going to set up a task, and then once that download task completes, call this block of code, right? There are other ways that you can do this. We've declared ourselves as a task delegate, which means we have access to some of the different functions. So we could have a progress on the download that gets called. We have a callback. A function that gets called from the protocol. Or we could also have a completion, right? So like when this download task completes, call this function rather than having a completion handler, right? So you can have progress indicators and completion indicators, right? And these are separate functions that it uses its delegate to call. The first task we're going to talk about is an NSURLSession data task. It's common to use the data task for putting together a GET request, right? So it uses blocks for completion, or what did I just say in the last slide? You can use a block for completion or a completion indicator. Good. All right. All right. So the function that we're going to use is data task with URL completion handler, right? Which means that we're going to give it a URL and we're going to have a completion handler. Okay? So for example, if we want to put together a URL, I'm going to say this is my get URL. And it's of type NSURL. And what I'm going to do is I'm going to use two NS strings, the base URL and the query, and I'm just going to concatenate them together and form this URL. Okay? Is that okay? That's good. So my base URL is the web server. Right? My query is a question mark and then the different arguments and their values that I want to send up. Okay? Those are both NS strings. So now I can say, okay, I want an NSURLSession data task, and that data task is equal to, I'm going to call a function on my session that I've already set up, right? In viewDidLoad or init with code or whatever it is, I've already set up this self.session using the code from a couple of slides ago, right? So I'm going to say data task with URL. I'm going to give it the URL I just created, and then I'm going to say, here's the completion handler. And the completion handler for this GET request has data, it has the response, and it has an error. What do you expect is inside the response?
The data that the server responded to.
Yeah, it's the response. Like it responds back with an HTTP, right? Like the response that you get from the server, it's going to have, okay, this was the request that you sent up to me. It's going to have some specifics about it, but the body of your HTTP request is going to be cast as an NS data right here. So you're going to get that back as data, right? So for instance, if I was querying this web server and I did a GET request and we're printing out to the screen, hello MSLC world, I'm going to get hello MSLC world back inside of this data variable, right? And it's going to be bytes of data, right?
So NSURL response is the whole thing, and data is the content.
NSURL response is essentially the header that comes back. Yeah, it's your status, right? If you got a 404, it's going to be inside of your response, right? Any code you get back, any status code, it's going to be inside the response, not in the data. Okay? Yeah? Happiness? Good. Okay. So essentially what I'm going to do inside of my completion handler, I'm just going to call a couple of NS logs, right? So I'm going to log the response, and I'm going to log this right here. So what I'm actually doing right here is I want to take data and I want to cast it back as an NS string, right? So the way that I do that is I call this function NSString alloc init with data, and I give it data. And I tell it the encoding is this encoding. So I can get it back from the server, right? Wonderful. That is a data task. Yeah, convert bytes to string. Any questions on the data task? Okay, there's one last little thing code that popped up down here. Data task, resume, and start the task. If I don't call this, I will create a data task and never execute it because it starts off, the default state is suspended. Unless I tell it to resume, it doesn't do anything, right? So you must call it or it stays suspended, right? But essentially, once you do that, it's going to kick off this, and the second that it completes, it calls this block of code. Right? And that block of code can do anything you want with the data that comes back.
After it executes one time, does it just like suspended?
No, say again.
Does it just execute once and then goes back to the suspended state, or?
It executes once and then it's gone. That data task is, unless you save the data task inside of a property somewhere, it's gone. It's set to nil. All right. Okay. NSURL download task. I'm going to go really quickly through this one because you can go on the iOS course and Stanford course and actually get through this one. It's a subclass of the NSURLSession data task. and it actually has a lot of delegate methods that you can use for getting progress indicators, right? So one of the things that we can do is create a download task where we want to actually download an image. Okay, so what I could do is I can set up this NSURL. So I'm going to say self.session, download task with URL, and then I'm going to give it a URL. And the URL that I gave it is some URL for downloading images.com/cool image. Okay, I'm pretty sure that doesn't exist. I can't be sure. I didn't test it. Okay, but I'm assuming that there's a cool image at that I want to download. Okay, so the completion handler that comes back is I get an NSURL location, the response, and the error. Okay? NSURL location. What is that? It's where in the file system that data has been downloaded to. It's file. Okay? So inside of this, I'm going to say, okay, if there's not an error, I'm going to create a UI image, and that image is going to be image with data. And I'm going to say NS data, data with the contents of URL, location. Okay? So I'm using data with the contents of URL for a local location. I'm not using it for going out onto the internet. Good? All right. And then download task, resume. Okay? You can also use delegation instead of the completion handler here. So you could, instead of giving this completion handler, you could just say download task equals self.session, download task with URL, and not give it a completion handler. And then what would happen is you get access to these as long as you implement these protocol methods. So this method is URLSession, download task, did finish downloading to URL, and it'll give you the location right there. So everything that we did up here we could do inside of the body of that function. But we also have access to this function, which is total bytes written and total bytes expected to write, right? So we get progress for this download. So we could do something with that, right? So it's the expected number of bytes that are going to be written and the total bytes that have been, right? So for very large files, this might be something we want to use. Okay. Last thing we're going to talk about for tasks is an NSURL upload task. And it's common to use this upload task for doing a post request, right? So essentially when you do this, you're going to need to set up your own HTTP request. Instead of giving it a URL that you want it to go to, you're going to have to set up a request. And inside of that request, you're going to have to set things like the URL, right? So when we want to use an NS upload task, we're going to use the function upload task with request from data with a completion handler. Okay, so the way that this function works is the first thing I'm going to do is I'm going to create this NS mutable URL request. And that request is going to be NS mutable URL request with URL, and I'm going to tell it the URL that this request is going to go to. All right, then I can say request set HTTP method post. All right, that's my post request. I have set up a post request. Okay, so now if I've got some, let's say I've got a UI image called image, I can set that image, I can compress it with JPEG compression and set it into this image data variable, right? What is this? What is image data? It's binary data, it's bytes. It is the JPEG compressed object right there. So what I want to do with this is I want to post it somewhere, to some website, to this post URL, right? So what I do is now I'm going to call this upload task with request, right? So I'll create a...
What is it, 0.25?
That's the compression that I want to do. I want to compress it to 0.25. Right? I could set that to 1, and it would be a lossless compression. That's not something we really get into with this class, but anyway, I did my master's thesis on that, so that's wonderful. So NSURLSession upload task. We could say this upload task is now equal to self.session, again, upload task with request now, and here's the request that we set up, from data, image data, okay? And then I'll give it a completion handler for what, if we upload that, we'll get a response back from the server, and we can do anything with the response, but essentially, we've now uploaded that image to our server, okay? Feel very happy about ourselves. Notice that this from data, this image data right here, That could be any data, right? It is an array of bytes. Okay, you can send anything through that, right? Then it's a post request. Okay. And we could also use delegate methods here if you wanted to, and that's kind of the main advantage of using the NSURL upload task, is you have access to some of those delegate methods for, okay, did I finish uploading, or how far am I in the upload progress? So you can put a progress indicator for something that's uploading. Okay. All right. The next thing that I would have to do is what? Resume. Bam. So I'm going to say upload task resume, but I didn't put it on the slides. Okay, so let's go back to this NSURL data task, right? So I showed you how to do a post request using the upload task, but what if you just wanted, the NSURL data task, you can actually make your own put and post requests that way, right? So let's talk about how you do that. It's highly similar to an upload task, except we don't get access to all of those delegate methods for looking at progress. So what we're going to do is very, very similar. I've got this mutable URL request. I'm going to say it's a post request. Here's my URL. Now I'm going to say, here's my image data, the same as we had before, but now I'm going to say request set HTTP body image data. I'm going to set exactly the image data right there. And now I can use my upload task the same way that we did 3 slides ago, which is essentially NSURLSession data task with request instead of with URL. So here's the request that I want it to carry out, and here's my completion handler. So I can do a post request with NSURL data task. And the next thing I'm going to do, resume. Okay? Okay. So now we know how to send some data from our iOS app, and we've got our web server that's running, our Tornado web server. Let's talk about JSON. Okay? So very, very common if we want to transport data between the server and our iOS application, we want it to actually have some structure to it, and JSON is a really good structure for us to use. Okay, so if I send a JSON object up to Tornado, then in Tornado and in Python, the way that I'm actually going to go through here and deserialize that, turn that into a dictionary, is I'm going to say import JSON, which is included with Python, batteries included. And I'm going to say class JSON post handler, and I'm going to say the data is equal to JSON.loads, and then I'm going to get the self.request body. Right? So I'm going to take the body that I've sent up from my iOS application, and as long as that body is JSON, it'll parse it and save it into data. Okay? I can do the same thing in iOS, where now, let's say I'm actually, so Tornado, I'm going to send this back down to my iOS application, and the HTTP body, that is set up as a JSON, same way that I've sent up. I can say that my response data is equal to NSJSON serialization, JSON object with data, right? All of the responses that we've gotten back, we use an NS data, right? So as long as that NS data is JSON, it's going to save it into this response data. And it's also going to tell me if there was an error trying to convert that over to JSON. Okay? In both of these scenarios, the output is a dictionary. Okay? This is Python code up here. This is a Python dictionary. This is Objective-C code down here. This is an NS dictionary, response data. Okay? Extremely similar, right? Okay? Let's say I wanted to serialize something in iOS, right? So let's say I've got this JSON upload variable right here, and it's an NS dictionary, right? I want to upload it to my Tornado web server. I'm going to say, okay, get me the data with the JSON object, right? So I give it my JSON, and I get back an NS data, and now I can post that using any post request that I have with this NS data. Right? So now I've got this really good methodology of sending JSON to the server, interpreting it at the server, sending JSON to my iOS application, interpreting it, and parsing it on my iOS application. Right? Why am I using JSON? Yeah, you can use it in pretty much any language. It's industry standard. I mean, lots of people use JSON. Okay? Especially for HTTP. All right, so we're going to do a demo. We are going to do a demo in 5 minutes about Tornado plus the iOS. We're going to send a GET request. We're going to handle that query in Tornado. Then I'm going to do a POST request with a GET-like query. And then I'm going to do a POST with JSON in it and JSON out. Okay? And next time, we will look at doing machine learning. And we will build a prototype A6 for you. Okay? I don't know if we'll do that next time. But we might do that with the following lecture. Okay? We're going to talk about machine learning and why we're taking the time to do all of this Tornado, MongoDB, HTTP request stuff. Because it's going to be super cool. Okay, we're going to go from kind of cool to super cool. And maybe you guys will actually be excited about it. Okay. Someone's excited. There's one person that's excited. There's 2 people. There's probably half of you are excited, but you just don't know how to express it. It's okay. You guys are competing in the NIT championship. How cool is that? Yeah, you can take it and you can like rub everybody's face in it, right? You're like, hey, we should have been in the March Madness. Anyway. All right, so here's an application that we have built now. Let's go ahead and pull this down. Yeah, we'll keep me up there. So I've got an NSURLSession, which is an ephemeral session configuration. And if I go into this application, I can look at my storyboard here. And this is what things look like. Don't pay any attention to any of these labels down here. Those mean nothing until next lecture. Okay? Pay attention to all the buttons up here where I can say, hey, send POST request, send POST as a JSON, and send a GET request. We're going to look at those 3 functions that we're doing from iOS. Okay, so let me go over here to my view controller.
What about the slider?
The slider? Now we'll talk about it next time. Essentially, I've got this little update argument where I'm updating self.value with the slider, right? So essentially, let's do a GET request first. Where's my GET request? Okay, send GET request right here. Whenever I click that button, I'm going to have a base URL, which is, it's going to go to my server URL at the extension get example. Okay? Right, so here's the get example. Then I'm going to formulate a query, which is here, which my argument is 0.045. Okay? Right? Actually, let's make my argument self.value. All right? Very good. You're going to give me a warning on here. What should I do here? Seriously? It doesn't. All right, so I'll get a float value back from self. So it's going to send up the slider value. Okay? Then I'm going to put together this NSURLSession data task. I'm going to upload it. And then whenever it comes back, I'm going to get a response. And I'm going to spit back out whatever the server has given me. Right? And the way that I'm going to do it is I'm going to take this data and I'm going to basically make it into an NS string and spit it out on the command line. Okay? So let's do that. Let's run this from Eric's phone. Build succeeded. Look at that. All right. Auto layout's off. I should count off for myself. Okay, so let's send a GET request. I got test of hello world back. If you look down here. Test of hello world. That was the data that I got back. Here is essentially my entire header that I got back in my URL. Right there. Oh my goodness. What on earth? Let's do this. Bam. I don't know how to make this bigger. I wish I could make this bigger, but it's some kind of status thing. Command plus, 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 does nothing. Intuitive. Someone email someone. Okay, so there's test of hello world, right? So if I went to my get example, inside of this thing that's running up here, if I look at tornado example, which is running, I've got, oh, get example, which calls test handler. And test handler is right there. Test of hello world. Wonderful. I'm feeling really good about myself. Okay, now, what else can I do here? Well, I can send a post request right here. Get out of the boy phone. So here is the post request that I can put together. The base URL goes to the extension do post right here. Then inside of my request body, I'm going to send up argument 1 is equal to 5.9. Okay. And then I'm going to issue this post request. Right. So post task is here. Data task with request. I give it the request. And then when it comes back, I'm going to say NS dictionary, JSON dictionary. I'm going to serialize the data that comes back inside of my completion handler. And then I'm going to spit out that dictionary onto the command line, right? So, what was that called? This was my send post request. All right, so the post request that I sent, this is kind of a get style post request. Why? Because the body essentially looks like a get request, right? Where I've got arg1 is equal to, %.4f, right? So inside of my web server, we're going up to do post. It's calling post handler as get arguments. Here's post handler as get arguments. Inside of post, it's going to say arg1 is equal to this. So hopefully it'll get 5.9 there. And then it's going to write back JSON. It's going to spit back the argument and then 4 times the argument there. Okay, so let's see what happens. So I will send post request. Oh my goodness. If I look back down here, essentially what I've got back is it's spitting out what that dictionary looks like, and it says arg1 equals 5.9, arg2 equals 23.6, which I assume is 4 times 5.9. Okay, but I can't do that on my head. We're done. It's 4:52. I apologize. 2 minutes over. Okay, so that is that. I will let you, on your own time, go ahead and look at the other example that I have right here, which is the send JSON post request. The only difference is the request body that's here is going to be set up through a JSON serialization. Okay, so I will send, I'll send that post request up to Tornado, and Tornado will actually do this JSON loads, and it'll get the JSON. It'll convert the JSON, save it into data. Okay? All right. Good. We're done. We're rocking this lecture out.
I'm gonna tell them about our idea, and then I'm gonna run back to the room.
Oh, nothing.
We have lots of money.
Did someone
Eric,
run out the door?
Huh.
I want to tell you. Can I have the phone back? I want to tell you about our idea, just in case someone else tells you about their idea and tries to steal our
Your idea?
So what we're thinking right now.
Yep.
It's a work in progress.
Wait, hold on, because you're actually on the
Video.
on the video.